Hi everyone, so now we are up to topic 2, lecture 3, part 3. Okay, so let's have a look at some concepts related to concentration. So if you look at the word concentration, we can refer back to it to the previous recording where we talked about solutions. So concentration is just the proportion of solute versus solvent. Okay, remember that before, when in our last recording we saw a solution, and the solution was made up of solute plus solvent. Okay, the concentration is just the proportions of each. Okay, if you have low concentration, okay, you don't have many solutes and you have high solvent. And if you have high concentration, you have more solute relative to solvent. Okay, so this is a diluted solution and this one is a concentrated solution. Okay. Okay, so there's different ways that we can actually describe the concentration of a solution. We can think of it in how much solute is present, okay? So we have this much solute in this volume, or we can express concentration as a percentage. So, the solution was 5% sugar, okay? Or the solution was 70% ethanol and the rest is water. So 70% ethanol is 70% ethanol, 30% water. Or another way that we can express concentration is by actually referring to the number of molecules that are present, okay, in a given volume. So how many molecules do you have in a certain volume? And that way of expressing concentration is referred to as molarity. Okay, so where did this come from? Well, there is a number that's called Avogadro's number. Sounds a lot like avocado. And what that number represents is 6 times 6.02 times 10 to the 23. Okay, so that number means this. It means 6.02 with lots and lots of zeros behind it. So if you were to write that number out, it would look like that. Okay, so 602 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that number there is equal to that number there. They're exactly the same thing. That is just scientific notation. But that and that are exactly the same thing. So Avogadro's number just means this many atoms. Just like if I say to you, look, can you just run down to Coles and get me a dozen eggs? Then you will get me 12 eggs. Okay? Now this, so 1 mole of a substance is always this. Okay? So 1 mole of a substance is always this many atoms. So if I ask you to go and just grab me a mole of hydrogen atoms, you would grab me this many hydrogen atoms. If I were to tell you, look, can you just run the streets and get me a mole of oxygen? Then you'll come back and you will have in your hand this many atoms of oxygen. Okay? So a mole just refers to a number. How does this apply to you as health professionals? Well, sometimes you need to understand test results. Let's have a look at this person. This is an actual blood, it's a blood work, a blood test. and it's got all the things that they tested for. Let's have a look at sodium, okay? And look at that, there's a reference range, right? Now, I've talked a lot about homeostasis and references, so you probably know what that means by now. Let's have a look here. This person's result is 161, and it's already got a star next to it because it's already flagged as being too high or too low. And the reference range is that. Now let's have a look and see what the hell does that mean, and how can we express that in a different way? So, first thing we need to understand is what a millimole is. So a millimole is 1/1000th of a mole, okay? So if we look at the number, 161 millimoles is the same as saying 161 divided by 1,000, which is equal to saying 0.161 moles. So 161 millimoles is exactly the same as 0.161 moles. It's just basic division. We know that 1 mole is equal to that many atoms. Okay? So what we can do is we can calculate how many atoms, okay, how many sodiums we have in that person's blood. So we've got 0.61 moles times that, it's going to give you this number. So this means that there are this many atoms of sodium in 1 litre of this person's blood, because it's millimoles per litre. Okay, millimoles per litre. So that's why it's useful to understand what moles are and what millimoles are and how that converts to actual physical atoms. Okay, so let's have a look at chemical reactions. Okay, so in a chemical reaction, we have bonds that are broken or created. You just remember when we talked about atoms, and we said we can never divide them, we can never destroy them. So all we can do is stick them together and break them apart. Okay, so the bits that you start off with are called reactants, and the bits that you end up with are called products. So chemical reactions is the action of rearranging atoms, and it involves energy, okay? So you can have energy being released, or you can have energy being absorbed, all right? So chemical reactions involve energy, that's the point. So there's a couple of different types of energy that we need to think about in this subject. The first one is called potential energy, and the other one is called kinetic energy. So remember that energy is the capacity for doing work, okay? So that's the kind of definition of energy. And you can't destroy energy and you can't create anything, all right? So we're going to look at 2 different forms of energy because that are important in anatomy and physiology. The first one is potential energy. That means that this bottle on the wall here, just sitting there, has stored energy only because of where it is. Now, kinetic energy is got to do with energy in motion, okay? So if the bottle is just sitting there, not doing anything, it's got potential energy. As soon as it moves, it now has kinetic energy. So energy can't be destroyed, okay? So we have to conserve. It's about the conservation of energy. Energy cannot be destroyed or created. It's just transferred and moved around. Yeah? So, we need to think about chemical reactions as well with regards to heat energy. Some chemical reactions release heat and they are called exothermic reactions, okay? So when you break these chemical bonds, sometimes energy or heat is released, energy is released. Another type of reaction is endothermic. So when you actually make new bonds, you actually absorb energy. So they are endothermic. All right, there's quite a few different types of chemical reactions that can happen in the human body. In this particular instance, you've got one atom and another atom, and all you're doing there is sticking them together or chemically bonding them. The opposite is true. You've got two atoms that are chemically bonded and you're just breaking them apart. Another thing that could happen is you're just moving atoms around, okay? So in this instance, you've got A and B bonded together and C and D bonded together, and a chemical reaction happens and then you just swap them around, okay? Nothing is lost, so no atoms are lost, no atoms are gained. All you're doing is sticking them together and pulling them apart. And then we saw this before, remember, when we did acids and bases. A reaction can go two ways, so you can actually have two atoms joined together and they can come apart, and they can join together and come apart, and they can do that as many times, yeah? Many times. Okay. Now, chemical reactions happen when molecules collide, okay? So that's what molecules need in order to get the chemical reaction to happen. And there are certain things that increase the rate of chemical reactions. So for example, if you have heaps and heaps of reactants, so if you've got more stuff in a certain space, it's going to collide more often. The more temperature you have, the more the molecules are going to move around, and there's going to be a greater chance that they're going to hit one another. And the other thing that increases your chemical reaction rate are things called catalysts, okay? Now, a catalyst is a very useful thing to have. Now, we're going to look at catalysts in the next recording, yeah? Because a catalyst speeds up your chemical reaction rate, so things happen faster, and they also are like matchmakers. They bring molecules together to make those chemical reactions work. So we're going to look at those when we look at proteins in a little bit more detail next. Okay, a couple more terms to kind of think about. What is metabolism? So metabolism isn't like you can go down to McDonald's and have a Big Mac and not put on weight. That's not metabolism. Metabolism is any chemical reaction that happens within your body, okay? Breaking down molecules, building them up. Any chemical reaction is metabolism, okay? Which means catabolism is you're breaking down a molecule into smaller parts. Animalism just means the opposite, is that you've got little molecules and you're sticking them all together to make one big molecule, okay? So there are just a few words that you need to kind of think about. All right, yay!